Graphing exponential functions is no different than graphing any other function. But the thing to pay attention to when graphing exponential functions is the base. Here I have a base of 2, a base of 3, and a base of 1/2. So 2 to the x, 3 to the x, 1/2 to the x. Here it's apparent that when we have a larger base, it increases more quickly. And as I discovered when I was multiplying things out for these different functions, 2 times 2 times 2 times 2, 3 times 3 times 3 times 3, for these different functions, here the y values are doubling every time an x is increased by 1. Every time x is increased by 1 for 3 to the x, it's tripling. So it is logical that the larger bases would increase faster, because instead of doubling for 2 to the x, this function 3 to the x is tripling. And another thing to notice for exponential functions, that the reciprocal is a reflection of the function. 1/2 to the x is a reflection of 2 to the x. And if I think about it, let's say I start taking points. Say for x is equal to 2 for these different functions. 2 squared is equal to 4. 1/2 squared is equal to 1/4. And if I did 3, 2 to the third is equal to 8. 1/2 to the third is equal to 1/8. And when we do negative x values, 2 to the minus 2 is equal to the reciprocal of 2 squared, which is 1/4. And 1/2 to the minus 2 is the reciprocal of 1/2 squared, which is 4. So that's why they are reflections of each other, because the reciprocal, if I put in a negative x value, it's going to be the reciprocal of it. That's the only other real, I guess, special feature of exponential functions to other functions. The transformations are exactly the same as any function. If a constant is being added or subtracted to the x, then there's a horizontal shift. If a constant is being added to the base function a to the x, then there's a vertical shift. There's a multiplication, then that's stretching or compressing to the base, and the reflections are exactly the same as previous. All transformations are the same for all types of functions. They just look different. The only thing I need to become accustomed to is just looking at the place where the x is being substituted in. Here, the x plus b up here is the same as f of x plus b, and it's no different than some regular polynomial, something like this. This is also a horizontal shift. So I won't spend too much time on these graphs. The only thing that one really needs to get accustomed to is just the fact that the base is the determining factor of what the graph looks like. Let me do one quick example. I won't spend much time on these. They are exactly the same as all other functions. we've been graphing. Take the function f of x is equal to minus 2x plus 2. The best thing, or the best place to start when presented with a function to graph is to think of what the base function is. And here the base function is 2 to the x. 2 to the x looks like this graph right here. I picture 2 to the x, and then I go back to my original equation, and I think of what is happening to this original graph 2 to the x. First off, there is a minus sign in front of it, which means that it is going to be reflected across the x-axis. So this 2 to the x with a minus sign in front of it is going to give us the same y values as this, but with a minus sign, which will reflect it across the x-axis. So instead of this pointing up this way, it is going to be pointing down this way towards negative infinity. But not only that, there is also this plus 2. So we have the reflection across the x and a plus 2 being added. So whatever y value I get from just plain 2 to the x, there's going to be 2 thrown on top of that, which is going to be a vertical shift of 2. So to forget about the minus 2x first, if it was just 2 to the x plus 2, it would be this graph, the same as this, but with an additional 2. So this graph would be shifted up 2 units. It would be up this 2 units, like that. So a vertical shift of plus 2. Those are the only 2 transformations taking place. Now that I know both transformations, I can graph it. Let me think of where it would be. So if I think of my regular graph, it would be 0, it would be 1 at 0. It would be 2 at 1. It would be 4 at 2. And it would be 8 at 3. Now what is taking place is that there's a reflection across the x-axis. So this point is going to be reflected from 1 to minus 1, and then is going to increase by 2. Well, let's put some points down here. Here it would be at 1, it would be 1/2. At minus 1, it would be 1/2. At minus 2, it would be 1/4. And it's not really necessary to do any more points. A little bit too small. So let me start with this one here. This is being reflected across the x-axis. Oh, instead of being at positive 1y, it's going to be at minus 1y, and then plus 2. So coincidentally, it's going to be the same point. But that won't continue. At 1, it is positive 2. So if we reflect this to minus 2, and then go up 2 units, that means it's going to be here. For x is equal to 2, y is equal to positive 4. Reflected across the x-axis, that is going to be minus 4, and then shifted up 2 units. For 3, x is equal to 3, y is equal to 8. Reflected across the x-axis, it's going to be minus 8, and then shifted up 2 units, it'll be minus 6. Now for these, at minus 1, x is equal to minus 1, y is equal to 1/2. So that is reflected across the x-axis, and then added 2. It'll be at 1.5, so about right there. For x is equal to minus 2, y is going to equal 1/4. Reflected across the x-axis, that means y is equal to minus 1/4 now. Now adding 2 will be 1 3/4. Right about there. So now I have a pretty good idea of what this graph looks like. It's going to approach 2 here. So 2 is an asymptote, a horizontal asymptote, in case you did not notice. And this is going to go to minus infinity. So here is our function, minus 2 to the x plus 2. And I may as well draw in the original one for comparison. I didn't mean for it to go up. This is 2 to the x. And I'm not really going to spend much time on this because it's just the same as regular transformations of any function. Any function that has been done in the past, it's the exact same method. The only difference is that it's an exponential function, and the only difference meaning that the location of where our x is has changed, but nothing else has changed. So use the same method.